Okay, chapter 9, section 1 is called translations. A lot of this you should have seen before. Okay, we're just going to talk about a couple of things of the shifting object is basically the idea. So by definition, a transformation is a movement, which they call a mapping, that results in the change of position, shape, or size of a figure. So transformation is just moving, changing size, all of it. There's like this big classification of transformation, okay? In the little image on the bottom, you see transformation A and B. So A is flipped over, right? B is flipped and shifted in a direction. This first image is called a pre-image. The second image is called the image. So where it was before, if you think about pre comes before, right? Where it was before is called the pre-image, and where it is after is the image. So on B, my pre-image is here, and my image is the result. So it goes from one to the other, okay? Pre-image, before, image, after. Rigid versus non-rigid motion. So if an object is moved using rigid motion, it does not lose its original shape and size. So they will be the exact same size they were before. They maybe have just flipped upside down or shifted to the right or diagonally to the left. They've moved around, but the shape is exactly the same. That would be rigid. So if you think about something that's rigid, it's unchanging, okay? A person that's rigid means they're usually like inflexible. It doesn't change. That's rigid. So transformations can be either rigid or non-rigid. Okay, you can take an object and stretch it, make it bigger. It's still a transformation, but that would be a non-rigid transformation. Example 1 says, tell whether the transformation appears to be rigid motion and explain. So the pre-image, you'll see the pre-image has the original letters, and the changed, the image itself has these little tick marks, like apostrophes. So this I know to be the pre-image, and this is the image. So if you look at A, does it appear as though the shape is the same? Size of the shape? Yes. So this is rigid. Shape is the same size. How about B? If this is my pre and this is my image, are they the same size? Definitely not. These are not rigid, and the reason is different size, shapes didn't stay the same, anything like that. Easy stuff, right?
Yeah.
Yes? David, you're getting all this with your double thumbs? Yeah? It's like a new skill that you can write with your thumbs. It's fantastic. You're very talented. Translation. So before it was called transformations. Transformations just means it's moving. But now within transformations, there's something called a translation. A translation is an object that slides in a direction. God bless you. God bless you. The object does not change size or shape, making the motion rigid. So it's still the same size and shape, which means it's rigid, but it's sliding. So it could slide to the right, it could slide to the left, it could slide up, it could slide down, but they slide in the same direction. God bless you. So again, in the examples that are there, here's my pre-image, here's my image. Each point has slid in the same direction. Same thing for the second one. Here's my pre and here's my image. And this time each point has slid in the same direction. They could go right, left, diagonal, up, down, any way they want, as long as they're all in the same direction, which again holds its shape. The apostrophes are the afters. The regulars are the befores, or the pre-image. But because this, like that first one actually showed you kind of like a path to follow, so you knew which one was the beginning and which one's the end. But if you look at the second one, how do you know which one's the pre-image and the image? Is the pre-image does not have an apostrophe and the image does. So that's how I know I started with the original EFD, and then I slid over and became the image that's on the right. And those have the apostrophes. All right, translating points. So this little notation, and it is super easy once it's explained in practice. It's super easy, but you got to understand it, okay? So if I take whatever point T is, whatever that was, and in this case, my X and Y, which is my coordinate points, and I do this little box here next to that T, this is telling me translate those points where the X, I would add a positive 2 to each X, and the Y, I would add a positive 4 to each Y. So think about your coordinate points. It's always X then Y. So the first thing is the change to the X, and the second thing is the change to the Y. So if I took the image that's here, I already have my 3 coordinate points, and I wanted to translate them. If I took -3, -1, and to the X I add 2, and to the Y I add 4, my new coordinate point would be what? -1, 3, which means my new coordinate point goes -1, 1, 2, 3. So let's call this A. This would be A apostrophe.
You're always adding to it?
It depends on if it's positive or negative. Good question. If it's positive, I add. If it's negative, I subtract. Okay, so now let's call this one B. If I have 0, 0, and I add 2 to the X and I add 4 to the Y, my new coordinate point is 2, 4. So I go up over 2, up 4, and I'm going to call that B prime. That little apostrophe is read as prime. Now, sorry? It's always what's here, so this will change. Yeah. So then that's C. So if I have -1, -2, I add 2, I add 4, I get? What's -1 plus 2? 1. What's -2 plus 4? 2. So my new point is 1, 2. And now I can find my image. So here's the pre-image. And here's the image. Good. It should be the same size, right?
Yeah.
Because this is just a translation. Still good? All right, so this says graph the image of each figure under the given translation. So now look at T, right? T is the translation, but what's next to it is -3, 4. What does that mean?
You have to subtract 3 and add 4.
Good. From every X, I'm going to subtract 3. From every Y, I'm going to add 4. So the first thing I got to do is actually figure out what these points are, because they're not labeled this time. So let's say I want to find R. R is here. Each of those tick marks is 2, right? That's what this means. So this is really 1, 2. So my original R is 1, 2. My original S, 4, 1. And my original T, good. So that was the first thing I had to do that I didn't have to do last time because it was labeled. So pay attention to your scale because this time they were 2. Now I have to subtract 3 and add 4. Subtract 3, add 4, subtract 3, add 4. So my R prime is -2, 6. My S prime is 1, 5. And my T prime is -1, 1. With me? Questions?
Why isn't it plus 2?
Because the little negatives on that 3. So if it was +3, I added. If it's -3, I'm going to subtract it. Same thing for 4. If that was a +4, I'd add it. If it was a -4, I'd subtract it. Now I'm going to plot my 3 new points. So -2, this is 2, right? Each little line is 2. 6, this would be 2, 4, 6. So this is R prime. 1, 5 means I go halfway, 2, 4, 5, S prime. And negative 1, 1, I go halfway and halfway, T prime. Because each tick mark on this graph has a 2 on it, right? So each one is 2, yeah. So pay attention to that. I'll probably not trick you, like on the quiz, it'll probably be by ones, but pay attention because that's like a standardized test thing. They'll always.
Can we take the quizzes online if they're not here?
Yeah, we'll figure it out. All right, so what are the coordinate points? Are they going by ones or twos this time? By one. So if I want to give the coordinate point to A, it would be what? Negative 2, 2. What's the coordinate point on B? 1, 1. And C? 0, negative 1. So those are all my original points, right? Then what's the change this time? Add 1 to X and subtract 4 from Y. Yep, and keep it negative.
That's a good song.
Shh. Oops, I did that wrong. Well, the bottom line would be 3, right? And there's no 5, but you can extend it. Please stop. Okay, so if I'm adding 1 to the X and subtracting 4 from the Y, then A prime becomes negative 1, negative 2, B prime 2, negative 3, and C prime 1, negative 5. Then you're going to plot your points, negative 1, negative 2, 2, negative 3, and 1, negative 5. I had to extend my graph a little bit, but that's fine. And then connect your points. It should again be the same shape, same size. So if you plot a wrong point and your triangle is not the same size, hopefully you can catch it because you shouldn't be changing sizes at this point, right? Should be the same size. Notability. Oh yeah, well there was one. But notability, you could also like draw that triangle, drag it down, and make sure it's the same size. That's something you could use to check. Questions on example 3? Who's still coming down? Okay. Now it's the reverse. Now I'm giving you the translated triangle. You need to give me the rule. What happened with these points? So what's the rule that describes the translation that maps triangle LMN to L prime, M prime, N prime? So the first thing I'm going to do again is figure out those points. Look at my lines again. What's happening?
It's by 1.
They're
Twos.
But they're going by twos, right? So if I wanted to name my original L, which is over here,
4, 1. All in line. Negative 4.
it'd be, well, it's in between here, right? So it's negative 5.
Oh, I was looking at N.
Oh, yeah. And then 2, 4. So negative 5, negative 4. That's L.
Can't you just take 1?
Yep. Now go to the new one, which is here. Right 1, down 1, 1, negative 1. Okay? How do I get from negative 5 to 1?
Add 4.
So close.
6.
1 minus a negative 5 becomes 1 plus 5 or 6. That's the translation. The prime minus the original. So I would do L prime minus L if you want to do it that way, if you don't want to just count. And that's the X change, right? The Y change went from the prime, which is negative 1, to the original, which is negative 4. Negative 1 minus a negative 4 becomes negative 1 plus 4, which is 3. So the change in X is 6. The change in Y is 3. If you're unsure, check another one. Yep.
Is that rising up to the occasion?
Yes. So M is here. This would be negative 2, negative 3, Original M is here. That's 4, 0. So if I did 4 minus a negative 2, again, I get positive 6. 0 minus a negative 3, again, I get positive 3. So I'm just confirming it by doing a second point, okay? And this translation is written as T 6, 3. And then you usually give the name of what you moved after it, which would be triangle LMN. This is what it would look like. Okay, T followed by the change. Make sure you do the X and then the Y, and then the name of the object that was moved.
Wait, was the other one saved to check it?
I did the red one just to check the blue one. You don't have to do them both. And you could do N. You could pick any 3 of the pairing. You just have to do one.